Hi guys, this is now the last lesson in indicator 19, and the learning target, I can solve rate problems including unit rates and percent. So here I am trying to record the fourth lesson of the day today, but that will complete indicator 19. Okay, now in this lesson we are basically talking about rate problems. And rate problems are totally related to distance, speed, and time. Okay, so when I talk about speed, first and foremost, when I talk about speed, speed is a rate. Speed is a rate. Please remember that. Okay, because think of it this way. When I say, and we had talked about it in this unit, that a rate is nothing but a ratio comparing two different quantities with different units. Okay, so think about speed. When your parent is driving on the highway, and let's say they're going at 70 miles in 1 hour. So look, when I write 70 miles over 1 hour, this is a different unit, this is a different unit, this is a unit rate. Because remember what we said a unit rate was? A unit rate is something in which the denominator is 1. I could have written 140 miles in 2 hours. And if I wrote that, that is a rate. That is your speed. So speed is always a rate. You're talking about, how far something is going, that. So 70 miles an hour, 80 meters in 20 seconds. So, per 20 seconds. So that is the speed. So thinking of that, speed is always a rate. So if I'm calculating distance, how far, let's say you're going in the highway, depends on your speed, how fast you are driving, which is a rate, times how long you are driving. So long, that means the time. Okay, so therefore, if you were to write this down, distance is equal to, I told you speed is a rate, so we write it as R times T. Now you don't have to put the times. If I'm writing the two variables next to each other, that means multiplication. So distance is equal to speed times time. Okay, now if I was to calculate the speed of something, all right, so I would have to think of, okay, let's say this is the distance that somebody is driving. And if you divide that by how many hours you've been driving, you actually get the speed. So speed would be nothing but distance divided by the time. Okay, so if I was to write this out, I would say speed, which is, we always write it as an R because it's a rate, is equal to D, which is distance, divided by time. Okay, so these are the two formulas you have got to know in this. Remember, speed is a rate because you are comparing two quantities with different units, and distance is equal to RT, and then speed is actually distance divided by time. Okay, so let's go ahead and we are going to solve some problems relating to finding either the distance or trying to find the speed of an object. All right, so let's say, let's take the first question. A peregrine falcon can dive at a speed of 80 meters per second. How far can it dive in 4 seconds? So first thing, always out of the three, you need to write down, what do you have? Do you have distance? Do you have the rate, which is speed, or do you have the time? So can dive at a speed. So speed is 80 meters over 1 second, because per second. How far? So far meaning how far you're going, that's the distance. So we don't know this. Okay? And then, can it dive in 4 seconds? So this is the time that is given to you. In 4 seconds, how far will this falcon fly? Okay? Or dive? So we know that distance is equal to speed times time. And we don't know what the distance is. So distance is equal to my speed is this. 80 meters per second. Okay, so this is my speed times the time, and the time over here is 4 seconds. Okay, so now what I can do over here is I can, because this is like a fraction and we have done fractions in the past, I can put this over 1 because this is a whole number, and then I cancel out the seconds with the seconds. Remember, anything from the numerator to the denominator which is the same can be simplified first. So I can just remove that, and so now I'm left with 80 times 4, and 80 times 4 gives me the distance of 320, and what is the unit left? Meters. Okay, the unit for meters is m. So this is the distance. Please don't put anything else, just write 320 meters because we are calculating the distance. Okay, don't make it into a rate, unit rate, or anything after this. Okay, so a peregrine falcon can dive at a speed of 320 meters and then in 4 seconds. So this is your distance that it can dive. So this is how you calculate. All right. Let's do the next problem. Okay. The next problem is saying that a giraffe runs at 880 yards per minute. How far can it run in 3 minutes? So we are again, I'm going to remove this and I'm going to remove this and see what I have, what I don't have. Okay. So giraffe runs at 880 yards per minute. So when you have 880 yards per minute, that's a rate. So that is the speed. Okay. So 880 yards over 1 minute is the speed of the giraffe. And how far? So we don't know how far the distance. It can run in 3 minutes. So here is your time that is asking. So using that formula, distance is equal to speed times time. I am going to do distance is equal to 880 yards over 1 minute. This is my speed times the time, which is 3 minutes. Okay, so this I can do over 1 like this. Minute and minute get cancelled out. And so then I'm left with D is equal to 880 yards times 3. And when I do 880 times 3, my distance is 2,640. I'm just thinking of the math in my head, but you all please do it, okay? 2,640 yards is the distance traveled by this giraffe in 3 minutes. Okay? Now, let's do one where we're trying to find the speed of something. Okay, so I'm going to erase this and this, because always write it out like this so you know what's missing and then what you need to be finding out. So the next question is, a great white shark swims 90 feet in 2.5 seconds. Okay, so in 2.5 seconds it is swimming 90 feet. All right, what is its speed? So now we need to do is we need to calculate the speed of this great white shark. Okay, so what is the distance it travels? It travels, it is swimming 90 feet in the time which is 2.5 seconds. What is its speed? Okay, so speed is determined by the distance it's swimming divided by the time. Okay, so if I do that, I have my distance is 90. Okay, so 90 feet is my distance and the time is 2.5 seconds. Okay, now you cannot leave it like this. You have got to simplify this. So I do 90 divided by 2.5 or 2 and 5/10. We have done dividing by decimals and the divisor cannot have a decimal. So we've got to get rid of that. So we move one place to the right. And if I do that, I go to the end of the whole number, move one place to the right also. So now I get 900 divided by 25, and then I'm going to start doing the math. 9 by 25 doesn't work. 90 by 25, yes. I know that 4 times 25 is going to give me 100, so that is going to be way higher. So it'll have to be 3 times 25 gives me 75. I cannot subtract 5 from 0, so I borrow from here and this becomes a 10. 10 minus 5 is 5 and 8 minus 7 is 1. I bring the 0 down and I know that 6 times 25 gives me 150. So therefore, my rate of this great white shark is 36 feet in 1 second. So this is the rate of this great white shark. Okay, that's how fast great white sharks can swim. Okay, 36 feet per second. Okay, let's do the one with the lion. And let's say the lion is running, or the lion runs at 288 feet in 4 seconds. What is its speed? So now, let me go ahead and erase this. And we've already said that speed is distance divided by time. So I am going to replace these values because it's running 288 feet in 4 seconds. So what is its speed? So I'm going to substitute the values now. Speed is equal to distance, which is 288 feet, and time is 4 seconds. Okay, now simplify it so you can find the unit rate, because that's what we're trying to do, is find the unit rate for speed. And I do 288 divided by 4, and I get 4 times 7 is 28, and I get 0. I bring the 8 down. 2 times 4 is 8, and I get 0. So the lion is running at the speed of 72 feet in 1 second, or 72 feet per second is the speed of this lion. Okay, then one last question. Let's talk about a hot air balloon rising, and the hot air balloon is rising 9 meters every 3 seconds. Okay, so 9 meters every 3 seconds. So how high does the hot air balloon rise in 15 seconds. All right. So when it's saying how high how high, when it's talking about high, means you are missing the distance, because how far is it going or how high is it going? So that basically means that the distance part is missing. Okay. But we'll go ahead and fill this out so you can see. All right. So a hot air balloon rises 9 meters every 3 seconds. So that is the speed. Okay. 9 meters every 3 seconds is the speed of the hot air balloon. And how high will it rise? So that is the distance, because how far is it going to go up? Okay. In the time 15 seconds. Okay. So now we know that distance is equal to speed times time. Okay. And so therefore we have D. Speed is 9 meters over 3 seconds times the time, which is 15 seconds. All right. So I'm going to show you, there are 2 ways you can do this. And then you put it over 1. And then second and second can be simplified. You are removing that. And then I can simplify the common factors. I'm going to find the greatest common factor from the numerator to the denominator. And I know that 3 divided by 3 is 1. And 15 divided by 3, I get 5. And so distance is 9 meters times 5, and the distance traveled by the hot air balloon is 45 meters. 45 meters. So this is the answer. And like, this is one way to do this. And another way that you could have done this, you could have made, see, if I'm saying distance is equal to RT, I could have converted the speed into a unit rate. Okay, so it's saying 9 meters over 3 seconds. So I could have just simplified here, made it into a unit rate, and unit rate means that this would become, my denominator would become 1 second. And so 9 divided by 3, I get 3 meters in 1 second. So if this was my rate, I would do times the time, which is 15 seconds. All right, and then over 1, and the second and second would cancel each other out, and the 3 times 15 would again give me the same answer, which is 45 meters. So you could have made it into a unit rate also and then solved it, or you can simplify before you multiply anything from the numerator to the denominator. The biggest mistake children make on this one is, so please don't make that mistake, they simplify it. Okay, so they might convert this to 5 and they convert this to the 1, and then they forget to multiply times 9, and they just write the answer as 5 meters. So don't do stuff like that. You still have to multiply from numerator to numerator, whatever is left over. If you think you are prone to forgetting, convert it to a unit rate first, like I did over here, and you did 3 over 1 times 15, and then if you already have that, all you do is 3 times 15 and you get 45. But this is what your rate problems will be. Please remember the formulas for distance and speed. Okay, and once again, guys, even if you had to calculate time, you would just have to do distance divided by speed. Okay, so but right now, just focus D is equal to RT, because distance is equal to the speed that you're traveling, 70 miles per hour or whatever, times how many hours you are traveling. That will give you the distance. And then in order to find speed, you would take, all right, this vehicle has gone so many miles. If I divide that by how many hours it's been traveling, I will get the speed of that vehicle. So that is how rate problems are solved. And that concludes our indicator 19. All right, guys, bye.